Yeah, good evening, Bellary students. Just a second, okay? Let me just set up everything. Give me a second. Path, good evening. And students who are joining from YouTube, good evening. Students, yes. Good evening, everyone. How are you all? Let me know. How are you all? So yeah, welcome back to today's session. My name is Samanmit, your physics faculty from Avantifellows. I'm here to what? Make sure that you understand physics. Yes or no? I hope till now whatever I have taught you have understood. Yes, students. Yeah, good path. Teerth, good evening. Parth, good evening. JNV Badari students, good evening. And students who are joining now, North Kendra, Sweetie, Teerth, Harshada, good evening. How are you all? And students who are joining from YouTube, good evening. Okay. Now, if that is the case, let us begin our class. All good, everyone. Shall we begin our class? Very nice. Good evening. Yes or no? Yes or no, students? Yes. Very nice. Okay, just a second. Okay, I see a thumbs up. Yes, very nice. I can see everything is set. Yes. We were talking about what, students? We were talking about work, energy, and power, right? We have already talked about work. Now we were what, heading towards energy. And today we'll be what, going deeper into what, something called potential energy. And already we have talked about it in yesterday's class. And also we'll be talking about like other types of what, potential energy today. Yes. So today the flow of class is something like this. Okay. First, we'll recall what I talked about in the last class. Then I'll give a recall question, a quick question to solve. It is very easy. Good evening, Abhay. Good evening. And we'll be talking about gravitational potential energy. Here, this one question, okay, it's a very interesting question. From this question, we'll be able to what, understand a concept called concept, that is what, DM mass concept. Okay, DM mass concept. ये DM वो वाला DM नहीं है, ठीक है? जो इंस्टाग्राम में डायरेक्ट मैसेज करते हो वो नहीं है, ठीक है, याद रखो। हरीश गुड इवनिंग, ठीक है ना, ये अलग डीएम है, ये मास का स्मॉल मास है, ओके, इज इट गुड? Then we'll be talking about what? Spring potential energy. From both the cases, we'll be solving some numericals. Okay, we'll be solving numericals based on it. Then the end of the class, that is summary. Is it good, students? Now, if that is the case, students, do you remember what we have talked in the last class? Let me know. Everyone has to tell. Coming from Suman to Tirth, everyone. Do you remember what we talked in the last class? Let me know, students. Why there is no reply from anyone? Okay, very good. Yes, very good, very good. Others, Suman, very nice. Now, what we talked about potential energy, yes or no? Where we told that there is no particular definition of what potential in physics, definition of what particular definition of potential energy in physics, but we talk about what change in potential energy. Yes, change in potential energy. And this change in potential energy, what we talk, students, that is delta U is equal to what? Minus of, yes, work done by, very good, sweetie, work done by conservative force, yes or no? Work done by conservative force. So we got the formula, the important formula, that UF minus UI is equal to minus what? Work done by the conservative force. And this is a very important formula. Yes or no, students? Do you remember this? Yes or no? Where what? UF is the final potential energy, and UI is the initial potential energy. Very good. North Canada students, have you gone through the lectures and are you able to understand? Janvi Vijayanagar students, good evening. Welcome to today's class. I guess you are attending for the first. Harish, very good. Are you attending for the first time? Janvi Vijayanagara? Or is it Davangere students? What? Okay, I can't see Davangere students. Bagalkot students, good evening. Ballari students, good evening. Let me know. Very nice. Then do you remember what we talked about? Do you remember? Yes? Yes or no? Yes or no, students? Where we? Yes, very nice. See, in yesterday's class, we took one example where if this was ground and this was two surface, I was lifting this mass M from H1 height to H2 height. So remember what was the change in potential energy we got? Yes or no? The work done that we got, or the change in potential energy we got? Yes or no? Yes, the work done was basically what, students? Minus mg h2 by h1. Yes or no? And also we got that work done by what? The potential energy, the difference in potential energy was what? Uf minus ui was mg by h2 minus h1. From here we what? We concluded that, or we got into the let's say conclusion that the change in potential energy delta U will be equal to this when we multiply by what? Negative sign. Yes or no? Then we prove that what? Delta U is equal to minus work done by the conservative force. Yes or no, students? Hope you remember this. Yes or no, students? This was H1, this was H2, this was the mass that was kept from M1 to H1 to H2. Very nice. Very nice. Yes. Now, okay, there was one concept that I forgot to tell you that. See, over here, we know that delta U is equal to minus work done by conservative force. Now, if I'm taking a small potential energy, small change in potential energy, can I write it as minus dWc? Yes or no, students? Can I write this? Yes? Let me know. And previously, we used to write that this change is small change in work done as what? Integration of F dot dx. Yes or no? The small change in this thing, potential energy. So can I write from here that integration of du from ui to u, what initial to u final, equal to what? Minus integration of F by conservative force dx. This is the formula, students. Got it? This is what I forgot to tell you. Let me know in the chat. Did you get it? What? See, you know that du is equal to minus dwc. That is small change in small work done. Small work done. Okay. And you know that this small work done is equal to what? How can we find the work done? See, you know that small work done was what? F dot dr. Yes, by or F dot dx. Yes or no? Now, if I wanted the whole work done, so that is what work done, the whole work done by the conservative force, I had to do the integration. Yes or no? I had to do the integration. This is equal to what? Work done by the conservative force. Now, can I substitute over here? Can I substitute this over here? What is H? JNV Yadgiri students? Yes, very good. So if I do the substitution, I'll get what? If there is a small change in potential energy, you go from what? Initial to final. Then you get the minus of integration of work done by conservative force and along whichever direction. I'm taking in along x direction. Along x direction. Okay, that is why I'm taking it to be what? Dx. Is it good? Let me know in the chat. Let me know, students. Is it good? Vijayanagar students. Okay, welcome to today's class, Yashaswini. Yes, very nice. Others? Let me know, Yashaswini, did you understand it or not till now? Yes. Very good, very nice. Now, if that is the case, can we go to a quick question? Can I ask you a question? Acha, okay, no problem. Can I ask you a question, students? And also, I have given a homework. Did I give a homework, students? Did I give a homework? 13. What is 13? What is 13 path? I didn't get you. What was the homework? Which was the question? Can I know? What was the force that is given? What was the force that is given? 3I plus 4J. This was the question. Acha, we solved in the, okay. Did we solve this question? There was a force given. F is equal to 3I cap plus 4J cap. And it was given that U of 0, 1 as 10 joule and U of 2, 3 as 0. As we need to find this one, the final velocity. Was it, this was the question, or the question was, I'll tell you the question, or the question was, F is equal to 2x and the potential energy was to find out at x equal to 1 was 10 joule and we need to find the potential energy. We had to find the potential energy at x equal to 2. Okay, very good. Okay, very nice. Okay, did you solve this? Were you able to solve this or not? Let me know. Were you able to solve this? What was the answer for this? Answer? What is the answer for this? 13. Achha, others, let me know in the chat what was the answer for the homework question. If you haven't done it, it is not that good. Achha, yeah, sweetie, what was the answer? Okay, this was solved. Do you remember the answer? The answer was 7 joule. It was not minus 13 joule, it was 7 joule. Yes? Did we solve it in the last class? Let us see. It was solved in the last class. It was 7 joule. That was the answer, right? This was the answer. Over here it is there. Okay, so make sure that you are checking the question, okay? You have checked the question very correctly. Okay, now if that is the case, students, let us do one thing. Okay, very good. वही तो मैं सोचूं कि होमवर्क तो क्लास में ही होगा. हाँ, yes, सब है. Okay. Now if that is the case, let us do a recall question now. Let us do a recall question. It's okay, Path, no problem. The question says, the force F is given as what? 3I cap plus 4J cap. The force is given. Now, it is given that potential energy, it is given that at U of 0, 1 to be 10 joule. Now, you need to find the potential energy at 2, 3. You need to find the potential energy at 2, 3. Students, I'm giving you exactly 2 minutes of time to solve this. This is very easy. So I'm giving less number of time. So please answer this question. Okay. So what? The force is given already. Yes. The initial potential energy is given. You can take this as initial potential energy. You need to find what? The final potential energy. Okay. Now you need to find which formula you have to take. Okay. So I'm giving you exactly 2 minutes of time. Please let me know the answer. Yes. So every JNV students who are present, Arshada, Suman, everyone has to answer. Okay. Bagalkot students, let me know. And Yashaswini, please let me know what is the answer for it. Harish, is there any doubt? Let me know in the chat. And also please answer the question. Okay. Please answer the question. I will give a hint now. See, you know that UF minus U initial is equal to work done by the conservative force. But, okay, sorry. But students, it is given as from potential energy 0, 1 and the potential energy from 2, 3. Okay, Yashaswini, very good. That is the right answer. Now use the equation work done equal to integration of fx dx plus integration of fy dy. Because we know that we already saw that work done by the conservative force can be taken as what? Integration of what, students? F dot dr. Yes or no? Yes. Now substitute over here. Yes. And also there is a minus sign over here. So use the minus sign over here. Okay. Sweetie Path, check your answer. Check your answer. Please check your answer. Yashaswini, very nice. Yes. No, sweetie. Okay, wait. Hold on. Just check the answer. Slowly check the answer. Okay. Don't do any rush. See, the time is up. Anyways, the time is up. Okay. Okay. Now, see. Over here, we know that one formula is known as UF minus UI equal to work done. Yes, minus work done. But here it is given that potential is what? Energy is ranging from U of 0, 1. That is what? Initial potential energy. And this is what? Final potential energy. We can't use the formula directly over here. Yes or no? Yes. Because we want the potential energy from 2, 3. That is why use the work done formula as what? Integration of fx dx and plus integration of fy dy. Why? We know that here fx is what? Fx is 3 and fy is what? 4. So can I use this? Students, let me know. Let me know, students. Let me know. Please let me know. Can I use this or not? Students, please answer it. Yes or no? Okay, can you hear me, students? Is there any disturbance? Okay. Now, see over here, can I tell this is x1, this is y1, this is x2, this is y2. So you know that the what fx is changing from x1 to x2 and what fy is changing from y1 to y2. Yes or no? Now, if that is the case, can I write this as fx? I know that is 3, that is changing from 0 to 2. 0 to 2 dx plus integration of what? From 1 to 3, from 1 to 3 and fy is 4 dy. Now students, if I integrate this, I'll get what? 3x 0 to 2 plus 4y 1 to 3. If I use the limits over here, I'll get from 2 to 3. 2 to 3, sir. Kya 2 to 3? I didn't get you. I didn't get you, Path. What is 2 to 3? Let me know, Path. What's the doubt here? See, Path, over here, how can it be 2 to 3? See, over here, this represents what? X1 and Y2, X2 and Y2. This represents X1 and Y1. The limit will be always from X1 to X2 or Y1 to Y2. Yes or no? Yes, very good. Now, if that is the case, if I apply limits over here, this will be, yes, that is a work done, Suman. Very good. That is 6 Yes or no? 6 minus 0 plus what? 4 plus 4 into 3, 12 minus 4. That will be what? 8. 8 plus 6 is 14 joules. Yes or no? That is the work done. Now you know that UF minus UI is equal to what? Work done minus work done. And you know that the initial potential energy is 10 joule. Yes or no? Now you want final potential energy minus 10 equal to what? 14. Yes or no? Minus 14. And UF is equal to minus 14 plus 10. And you get the final potential energy to be minus 4 joule. Yes, this was your answer, students. Let me know, students. Yadgiri, Vijayanagara, North Canara, Bagalkot, Ballari students, did you understand it or not? Let me know in the chat. Clear, very good. Others? Okay. JNV students, none of the JNV students isn't replying, is replying. Let me know. Okay, with the thumbs up. Okay. Bagalkot students, very good. Others, North Canara students? Okay. Ballari students? Ballari and Yadgiri students, let me know. And I don't see a reply from Vijayanagara students. Is there any doubt? Okay. See, make sure that is what I'm saying. Unless and until JNV students tell me that the doubt is clear, I can't understand what is going on. Okay. Very nice. Okay. Yeah. So I'm telling you again, students, JNV students, basically Ballari and Vijayanagara students and Yadgiri students, let me know if there is any doubt. Okay. I'll be proceeding from here. Now. Okay. Yes, if that is the case, students, then we'll be what? Talking about, okay, there is a homework question for you guys actually. I wanted to give a homework question. The homework question says, okay, please note it down. Please note it down. The force is given as x square I cap plus y j cap plus z square k cap. Okay? And U potential energy is given as 0, 1, 1 to be 10 joule, and you need to find the potential energy at 2, 3, 2. This you need to find. Okay, you need to find this. Find this. Yes, did you note it down, students? Let me know. Did you note it down? Krishna, Tirth, let me know. Sweetie Path, Suman and Abhay, did you note it down? Can I go forward? Yes. Okay, very good. Can I go forward? Very nice. So what? The force is given. It's a similar case of like last question. You need to solve the same thing. What? You know that UF minus UI is equal to minus work done. But you know that work done can be written as what? Integration of fx dx. See, over here it is what? X, Y, and Z. Three coordinate hai na? So that is what? Fy dy plus fz dz. Now find what is work done. Put over here and try to find what is the final velocity. That is a hint. Okay. Very nice. Okay. If that is the case, students, then we are going to talk about what? Gravitational potential energy. The thing is, we are not actually go into deeper into gravitational potential energy. As I said, we'll be talking about it in what? Gravitational chapter. Okay. We are going to talk about it in gravitational chapter. But I actually wanted to give a brief idea of what happens to gravitational potential energy. What is the formula for gravitational potential energy? Do you anyone know? Does anyone know, or can anyone tell, or can I know that, or may I know that what is the formula for gravitational potential energy? Do you remember? If there are two bodies, M1 and M2, if there are two bodies M1 and M2, what? And it is kept at a distance r, then the gravitational potential energy is what, students? Let me know. Let me know. Can you do you remember? Basically, the gravitational potential energy is what? Minus g m1 m2 by r, students. Please remember this. Okay. Here, basically, there are assumptions that are made. See, don't worry. We are going to prove this. We are going to prove this in gravitational chapter. We are going to prove this in gravitational chapter. Yes, Abhay, Path. Is it good? So the assumptions that are made here are that here, see, what we do is, if there is a surface, if there is a surface, okay, we take that the potential in a surface to be 0, okay, and I keep the object from what, from surface to height h, yes, then we take what, students, the potential energy u is equal to what, at height h is u is equal to mgh. Is it good? Yes, is it good? See, over here, always remember that you take u is equal to mgh when you, there is a surface. This is the surface, okay, and the surface has what, the potential energy as 0. Then if you are moving an object from 0, from the surface to a particular height h, then you consider what, the potential energy to be u is equal to mgh. And always remember, students, this h is not very large. जब तक ये large नहीं है, then u is equal to mgh is valid. Yes, if h becomes very large, it is not valid. Okay, so don't worry, we'll be going to solve this in gravitational chapter. Harish, just a second. In homework question, it is x square plus I cap plus yj cap plus z square. Okay, it is z square. Is it good? So f is equal to what? F is equal to x square plus y, x square I cap plus y j cap plus z square k cap. Yes, Harish, is it good? Yes. Very nice. Now, if that is the case, so here, did you understand what is the gravitational potential energy? It is given as, this is the formula. Please remember this or please note it down. Is it good, students? Yes, very good, very nice. Okay. Davangere students, welcome to today's class. How are you all? Now, if that is the case, students, see, over here, we are going to talk about numerous questions, okay? In that, one type of question is, if there is a chain, if I have a chain, and I have kept the chain along, there is a surface, okay? There is a surface over here. And I have kept the chain over here. Okay, the first position is something like this. This is a chain. This is my chain, and I have kept at a distance h, at a height h, and other position is this position. This is my chain, okay, and I have kept at a position. It is kept as at h height, but it has kept as vertical. And next, I have kept the chain over here. Okay, this is at h. Is it good, students? Is it good? Now, students, over here, there are 3 scenarios. This is 1 scenario, this is 2 scenario, second scenario, this is 3rd scenarios. As I said, students, we take the potential energy at ground to be 0. Now, students, what will be the potential energy of the chain at the first scenario? Can anyone tell me? If the mass of the chain is m, if m is the mass of chain, m is the mass of chain. Very good. What? This potential energy is mgh. Yes. Can anyone tell what is the potential energy over here? Can anyone tell, if I have kept the chain something like this, vertical, what is the potential energy of this chain? Okay. Can anyone tell? Or don't worry, students. In the next chapter, we are going to talk about what? Center of mass. Yes. Here, yes, Abhay, no problem. Here, students, the center of mass will be over here, and this will be at height h by 2. Okay. Then, if that is the case, the potential energy will be mgh by 2. Okay. And also remember, students, this potential energy for this chain will be 0. Why I'm telling is, in coming classes, we are going to shift into center of masses. Okay. There you need to try to understand that we are going to talk about potential also. So the questions will be something similar this. Okay. So first question says that if I kept a chain over here, what is the potential energy over here? Or the second scenario where I kept the chain vertical, what is the potential energy over here? Yes. Here we can solve this problem using the center of mass. Okay. And the center of mass over here is given at h by 2. Okay. So that is how we solve this. And also, as I said, when you keep at surface, when it is at surface, the potential energy is zero. So students, can I say the potential energy by first scenario is greater than potential energy of second scenario, which is greater than potential energy by third scenario? Yes or no? See, this is basically everything is very numerical because we are going to talk about potential energy. Why? Why, students? Potential energy is what? An invisible energy, students. Is it a? It is a invisible energy. Yes or no? And it is available only for what? Conservative force. Conservative force. Yes or no? That is why over here everything is what? Numericals. Okay? Everything is like equations, equations, equations. Okay, nahi? Three. What is that? Let's say movie of America. Not American, where there is a child who can't actually read stuff very clearly. He tries to help him. क्या था वो? कौन सा मूवी था? वेरी गुड. हाँ, तारे जमीन पर. यस. तो ऐसा मत सोचना कि तारे जमीन पर हो रहा है, ठीक है? ये सब लॉजिकली बोल रहे हैं, ठीक है? इज इट गुड? यस. स्टूडेंट्स, लेट मी नो. Let me know. Davangere, Bagalkot students, Ballari students, North Canara, Yadgiri students. Tir Trishna, is it clear? Okay. बहुत कुछ हो रहा है ना भाई. बात बहुत ज्यादा ही हो रहा है ना. Yes. Let me know, students. ज्यादा हो गया क्या? अच्छा अच्छा. Okay. Now, अगर ज्यादा नहीं हुआ तो एक प्रॉब्लम दे दूं क्या? एक प्रॉब्लम दे दूं. प्रॉब्लम कुछ नहीं है, बहुत सिंपल है. दे सकता हूं? Let me know. JNV students. Why there isn't any reply from JNV students? Can I know the reason, please? The reason behind it. Davangere students, Bagalkot, Ballari, North Canara, Vijayanagara, Yadgiri students. What is the issue? Now, let me know. Okay, I'm giving a question. It is just a trying question. Okay, you can just try it. Don't worry. I'll explain it how to do. But I want you first for 2 minutes. Acha, okay, Path. Okay, no problem, no problem. Even if the possibility is less than, if it is less than 50%, it's fine. Okay. The question says, okay, there is a chain. There is a chain, and it is kept something like this. If there is a chain, okay, let me take this, or let me take this. ठीक है, ये वाला. ठीक है. यहाँ मेरे पास एक चेन है और वो चेन ऐसा रखा है. ठीक है. This is my red color is my chain. Okay. Red color is this is my chain. Yes. Now the question says, let's say this is R and this is also R, obviously. Now the question says, find what is the potential energy. What is the potential energy of chain? What is the potential energy of chain? Students, let me know how can we solve this problem. What is potential energy of this chain? Can anyone tell me how can we prove this? Let's say the mass of the chain is m. Mass of chain. I'll give you 1 minute of time to think about it. What can we do? What can be done? Okay, the hint is at the surface, take potential to be zero. That is the hint. At the surface, take the potential as to be zero. सर ये तो आपने सिखाया है, ये है. अबे I didn't get you. Okay, the light has gone, so the video is something like this. Okay, so I'm offing the video. Okay, students, please let me know. Please let me know. Okay, so can you hear me? Students, can you hear me? Harish, which one I have to explain? Students, let me know. Students, let me know. Let me know in the chat. Okay, good, very good. Others, tell me, students, is it audible or not? Yes, very good. Now, okay, gravitational potential energy. Harish, okay. Harish, let's do one thing. I'll explain it again after this problem. Okay, Harish, is it good? I'll explain it again after this problem. Now, okay, very good, very good. Now, how to solve this problem? The thing is, here we are going to what? Learn a concept called DM mass. मैंने बताया ना, एक कॉन्सेप्ट हम सीखेंगे DM mass. ये DMS क्या है और किस चीज के लिए हेल्प करेगा? ओके, this will help us in basically center of mass. Okay, in what? Center of mass. Is it good? Yes or no? So see, the thing is, I'm going to talk about this concept to make sure that when we go into center of mass, everything is clear. So what is this concept? How can we understand this? So see, you know that, देखो, एक सरफेस था, एक मिनट रुको, एक सरफेस था एंड मैंने ये ड्रॉ किया है कि नहीं, ये वाला ड्रॉ किया, ठीक है, और एक चेन था, देयर वाज दिस चेन, ठीक है। अभी मुझे ये बताओ, अगर ये वाला चेन है और आपको पता है ये रेडियस आर है, ये रेडियस आर है, सो द डीएम मास इज बेसिकली टेलिंग दैट वी नीड टू टेक अ स्मॉल मास ओवर हियर, स्टूडेंट्स। सो अगर मैंने इस मास लिया, ये वाला डीएम मास होगा ना, स्मॉल मास, यस और नो, एंड दिस विल बी एट अ हाइट h1, कैन आई से दिस h1, यस और नो। सिमिलरली मैं यहाँ एक स्मॉल मास लूंगा, तो कैन आई टेक द हाइट h2, and if I want the small mass over here, and this is at a height, sorry, this is at a height h3, can I take, students? Let me know in the chat. This is h3, ले सकता हूँ? Yes or no, students? Yes or no? Let me know. And also I take the surface potential energy to be 0. Okay, now students, अगर मेरे पास स्मॉल मास है, मैं इस स्मॉल मास को पोटेंशियल एनर्जी फाइंड आउट कर सकता हूं, है कि नहीं? वो क्या होता है, देखो, आपको पता है कि स्मॉल मास है, तो मान लो पोटेंशियल एनर्जी फॉर स्मॉल मास, तो कैसे कर सकते हो? DmgH1 कर सकता हूं, ऐसे, है कि नहीं? सिमिलरली फॉर दिस U इज इक्वल टू DmgH2, ऐसे कर सकता हूं? यस और नो, स्टूडेंट्स, फॉर द स्मॉल मास? Yes or no? Then students, can I say I can find the small mass, this is small potential energy, the small potential energy as mgh, है कि नहीं students? And मुझे ये बताओ, अगर मुझे इस सबका मास चाहिए, टोटल पोटेंशियल एनर्जी चाहिए, तो मुझे क्या करना पड़ेगा? इंटीग्रेट करना पड़ेगा, ऐसा नो? इफ यू इंटीग्रेट तो हमें पूरा मास मिल जाएगा ना, पूरा मास का पोटेंशियल एनर्जी मिल जाएगा, विल गेट पोटेंशियल एनर्जी ऑफ होल चेन, yes or no? Let me know in the chat, students. Okay, Davangere students, Abhay, Path, Tir, Trishna, what is happening? Are you able to understand or not? Okay, Abhay, I'll explain it. See, over here, yeah, I'll explain it again. Over here I have kept a chain. Okay, now the thing is, the chain is kept along this direction. Yes, over here there are different heights, yes or no? Height कुछ अलग अलग है. Can you find the potential energy directly? Potential energy directly find out कर सकते हो? नहीं ना, वो डायरेक्टली नहीं कर सकते हो। इसलिए मैंने क्या किया, मैंने दिमाग लगाया, मैंने बोला कि आई विल फाइंड आउट स्मॉल मास के लिए मैं पोटेंशियल एनर्जी फाइंड आउट करूंगा। तो स्मॉल मास के लिए पोटेंशियल एनर्जी क्या होगा? ये वाला होगा ना, है कि नहीं? ये वाला होगा। अगर ये स्मॉल मास के लिए हमें फाइंड आउट कर रहे हैं जो पोटेंशियल एनर्जी है, वी आर एबल टू फाइंड आउट द पोटेंशियल एनर्जी फॉर स्मॉल मास, तो पूरा मास के लिए कैसे फाइंड आउट कर सकते हैं? इंटीग्रेट ना, क्यों मैं ऐड कर सकता हूँ ना, u1 u2 du1 प्लस du2 प्लस du3 ऐसे ऐड कर सकता हूँ, है कि नहीं? तो अगर ऐड करना है तो आपको पता है कि क्या करना पड़ेगा, इंटीग्रेट करना पड़ेगा। तो इंटीग्रेट किया तो सब कुछ आ जाएगा, है कि नहीं? यस, वेरी गुड। नाउ स्टूडेंट्स, हियर द कॉन्सेप्ट इज बेसिकली, ट्राई टू अंडरस्टैंड हियर इज, देखो एक मिनट रुको, कॉन्सेप्ट क्या बोलता है, देखो आपके पास चेन था, ठीक है, आपके पास क्या था, चेन था। नाउ ये बताओ, अगर मैंने यहाँ एक स्मॉल डीएम मास लिया, अगर स्मॉल डीएम मास लिया, ये स्मॉल है, ठीक है, कैन आई पॉइंट फ्रॉम, ये मान लो ये एक पॉइंट है, यहाँ से ये आर है, ये आर है, तो मैं यहाँ से अगर इसको ऐसे करूं तो ये वाला एंगल क्या होगा, डी थीटा होगा ना, ये स्मॉल एंगल होगा। यस और नो स्टूडेंट्स, लेट मी नो, लेट मी नो। देखो क्या हो रहा है, ओके लाइट आ गया, तो क्या हो रहा है, देखो यहां से मैंने क्या किया, एक स्मॉल मास डीएम लिया, ये क्या है, ये स्मॉल मास डीएम है कि नहीं? अगर मैंने ये स्मॉल मास डीएम लिया, देन इफ आई एम ड्रॉइंग टू लाइंस फ्रॉम हियर, एक पॉइंट से इधर से और एक इधर से, ठीक है, अरे एक मिनट रुको, एक मिनट रुको, एक इधर से इधर और इधर से इधर, तो ये जो वाला एंगल है, ये जो वाला एंगल है, ये डी थीटा मान सकता हूँ, स्मॉल एंगल मान सकता हूँ, और मैं ये मानूंगा ये एंगल थीटा है, मान सकता हूँ, यहां तक सही है, मैथमेटिक्स है, सब कुछ मैथमेटिक्स है, मान सकता हूँ। स्टूडेंट्स लेट मी नो, स्टूडेंट्स लेट मी नो। यस, हाँ, देखो ये बताओ, ये वाला आर होगा ना, ये वाला लेंथ आर होगा, यस और नो? मुझे ये बताओ, अगर ऐसा ही कुछ दिया है, ये वाला एंगल आर है, ये वाला एंगल थीटा है, तो कैन आई रिजल्ट इन टू कंपोनेंट्स, दैट इज आर कॉस थीटा इनटू व्हाट, आर साइन थीटा, कर सकता हूं, यस और नो? यस। तो मुझे बताओ, कैन आई टेल दिस हाइट एज व्हाट, आर क्या होगा, ये आर साइन थीटा होगा, यस, पूरा मैथमेटिक्स है, पार्ट स्वीटी, लेट मी नो, and Davangere students, let me know. Yes, so what I'm doing, there is a chain, I took a small mass and I'm connecting from the origin, ठीक है, यहाँ से सेंटर से, सॉरी ये सेंटर से मैं क्या करूंगा, दो लाइन ज्वाइन करूंगा उस स्मॉल मास को, वो स्मॉल इतना छोटा होगा ना, उसके पीछे एक एंगल होगा डी थीटा, स्मॉल थीटा, आई एम टेकिंग दिस एंगल इज थीटा, एंड यू नो दैट ये वाला तो आर ही होगा ना, क्यों, रेडियस है, ऑब्वियसली आर ही होगा। So if this is r, then I have two components, r cos theta, r sin theta. If that is the case, ये वाला क्या होगा, ये वाला हाइट r sin theta होगा। Very nice, everything is good. Yes or no? Yes. Now, if that is the case, students, can I write the potential energy du as कौन सा, du क्या होगा, small potential energy क्या होगा students, small mass dm, है कि नहीं? Yes or no? And g and the height, what is the height, इसका हाइट क्या है बताओ, what is height r sin theta, yes, very good। ये क्या है, एक मास के लिए होगा ना, तो ये एक मास के लिए होगा, that is for one small mass। अगर मुझे ऐसे ही पूरा मास के लिए चाहिए, मतलब इस मास के लिए, इस मास के लिए, इस मास के लिए, इस मास के लिए चाहिए, तो मैं इसको इंटीग्रेट करूंगा तो हो जाएगा ना, इंटीग्रेशन ऑफ डी यू इज इक्वल टू इंटीग्रेशन ऑफ डी एम जी आर साइन थीटा हो जाएगा, है कि नहीं? कहां से कहां तक इंटीग्रेट कर सकते हो स्टूडेंट्स, कैन आई इंटीग्रेट फ्रॉम, ये क्या है, जीरो, यहां से कहां तक, 90 डिग्री से, यस और नो? अगर देखो ये वाला पूरा है, ये वाला जो है ये पूरा चेन है, ठीक है, मैंने क्या लिया, चेन का एक हिस्सा लिया, दैट इज डीएम हिस्सा लिया, तो मैंने बोला कि उस डीएम हिस्सा के लिए, दैट स्मॉल डीएम मास के लिए पोटेंशियल एनर्जी क्या आ रहा है, डीएम दैट स्मॉल डीएम मास एम जी आर साइन थीटा, वो स्मॉल है, मुझे हर मास के लिए चाहिए, हर टोटल चेन के लिए चाहिए, तो मुझे क्या आ जाएगा, इंटीग्रेट करूंगा, लेकिन मैं इंटीग्रेट कहां से करूंगा, ये यहां से चेन यहां तक ना, ये वाला, तो 0 से 90 डिग्री कर सकता हूँ? यस और नो स्टूडेंट्स? 0 to 90 डिग्री कर सकता हूँ? सो 0 से π/2 तक कर सकता हूँ, तब मुझे पूरा का मास मिल जाएगा। वेरी गुड, वेरी नाइस। पाथ, लेट मी नो। यस, so what we got till now, we got that integration of du is equal to, if you do the integration, the total potential energy is equal to from 0 to π/2 what, dm g r sin theta। ठीक है, यहां तक मिला। लेकिन हम इसको सॉल्व कैसे कर सकते हैं? दिमाग लगाओ, सॉल्व कैसे कर सकते हैं? सोचो। सी, आपको पता है कि जो आप इंटीग्रेशन करते हो एक्स स्क्वायर, अगर dx है तो कर सकते हो। सिमिलरली अगर आप इंटीग्रेशन y को करना है तो dy होनी चाहिए, है कि नहीं? तो यहां भी अगर आप dm या r या g या sin थीटा कर रहे हो, तो हमें क्या करना पड़ेगा? तो हमें एक वेरिएबल लेकर आना पड़ेगा सच दैट आइदर इट इज इन व्हाट, dm g r या sin थीटा, है कि नहीं? लेकिन आपको पता है g एंड r कांस्टेंट है, ये दोनों कांस्टेंट है, यस और नो? एंड आपको पता है जीएम एंड थीटा वेरिएबल है ना, थीटा वेरिएबल हो सकता है, क्यों नहीं? थीटा वेरिएबल होगा ना। देखो, मैंने यहाँ का मास लिया डीएम, यहाँ का मास लिया डीएम, तो मुझे ही बताओ अगर मैं यहाँ से यहाँ लाइन खींचूंगा तो ये वाला एंगल थीटा होगा ना, यस और नो? सो थीटा वेरिएबल होगा। फिर से ही मैंने अगर इस मास का लिया तो यहाँ से यहाँ मैंने लाइन खींचा तो ये वाला एंगल थीटा होगा ना, तो थीटा वेरिएबल है। तो either have to bring dm in terms of dm the variable, मतलब मान लो ये अगर dm है तो मुझे मतलब यहाँ एक वेरिएबल आना चाहिए, जो अगर ये dm है तो एक वेरिएबल आना चाहिए m, या फिर जो साइन थीटा आ रहा है, अगर साइन थीटा है मुझे डी थीटा लेकर आना। समझे आप? अगर इसको सॉल्व करना है। डिड यू गेट इट स्टूडेंट्स? लेट मी नो, स्टूडेंट्स, डिड यू गेट इट और नॉट? एवरीवन यस? नाउ वेरी गुड। अगर ऐसा है तो मुझे ये बताओ, मैं इस आर को ले सकता हूँ, इस वाले जो आर्क है ना, जो मैंने आर्क लिया, ये जो सी से मैं जो मैं आर्क ले रहा हूँ वो ले सकता हूँ, ये वाला आर्क, ये वाला आर्क ले सकता हूँ। कैन आई टेक दैट? इफ आई टेक दैट स्टूडेंट्स, इफ आई टेक दैट, देखो मैं उसका जूम वर्जन लिखूंगा, जूम वाला, ये ऐसा होगा ना, ऐसा कुछ होगा, ऐसा कुछ होगा। ये डी थीटा है, ये आर है, यस और नो? ये आर है। तो मुझे ये बताओ इसका लेंथ क्या होगा? ये आर्क है, ये आर्क है, तो आर्क क्या होगा? व्हाट विल बी आर्क? व्हाट इज द लेंथ ऑफ आर्क? और लेंथ ऑफ आर्क, द लेंथ ऑफ आर्क, यस और नो स्टूडेंट्स? लेट मी नो, व्हाट इज द लेंथ ऑफ आर्क? याद है? याद है आपको? याद नहीं है क्या? व्हाट लेंथ ऑफ आर्क? अरे मैथमेटिक्स में नहीं पढ़ा क्या? लेंथ ऑफ आर्क क्या होता है? आर, आर डी थीटा होता है ना, आर डी थीटा, ये होता है लेंथ ऑफ आर्क, है कि नहीं? एंगल इनटू द रेडियस, ये वाला होता है। ओके, दिस इज द लेंथ ऑफ आर्क। नाउ स्टूडेंट्स, नाउ यू नो दैट जो ये वाला है ये क्या दे रहा है? लेंथ दे रहा है। ये देखो हमें ये मिला, ये मिला, क्या मिला हमें? लेंथ मिला, है कि नहीं? लेंथ मिला। लेकिन मुझे ये चाहिए कि आई वांट टू नो व्हाट इज डीएम, मतलब स्मॉल मास का क्या वैल्यू होता है वो मुझे जानना है। डिड यू गेट इट? यस और नो स्टूडेंट्स? यस। सी देखो, अभी हमें पता है कि होल मास का मास इज m। यस और नो स्टूडेंट्स? लेट मी नो, यस और नो स्टूडेंट्स? अगर होल मास ऑफ m है, मतलब ये जो पूरा मास है, ये जो पूरा मास है वो m है, दैट इज m। यस, यस और नो? नाउ अगर होल चेन का मास, होल चेन मास इज m, देन लेंथ ऑफ चेन क्या है? लेंथ ऑफ चेन क्या होगा? विल इट बी पाई आर बाई टू? विल इट बी पाई आर बाई टू? लेट मी नो। देखो ऐसा था, ठीक है, ये एक मिनट रुको, लेट मी ड्रॉ ओवर हियर। ठीक है, ये चेन था, ठीक है, ये चेन था, ये अगर मैंने m लिया आपको पता है अगर एक सर्कल है तो सर्कल का पूरा अगर मैंने चक्कर काटा तो क्या होता है लेंथ, अगर पूरा चक्कर काटा तो लेंथ क्या होता है, पूरा चक्कर काटा, you know that length is what, 2 pi r, circumference. Very good. Now if that is a case, अगर मैंने उसका आधा चक्कर काटा, सिर्फ आधा चक्कर काटा, if I आधा चक्कर काटा तो that is pi r. Now over here मैं कितना चक्कर काट रहा हूं, मैं सिर्फ उसका आधा चक्कर काट रहा हूं ना, इतना, so that will be pi r by 2, yes or no? This will be pi r by 2, yes or no? Yes, that is how I got pi r by 2, students. Did you get it? Yes or no? Let me know in the chat. जिसको समझ में है, let me know. And JNV students, let me know in the chat. This is pi r by 2. Yes, very good. Now, but I want what? देखो, आपको पता है कि m मास के लिए जो लेंथ हो रहा है वो pi r by 2 है, लेकिन मुझे कौन सा लेंथ चाहिए, कौन सा लेंथ चाहिए, मुझे dm का चाहिए, बस उसका लेंथ क्या है मुझे फाइंड आउट करना है. देखो यहाँ जो लेंथ आ रहा है ना, यहाँ जो लेंथ आ रहा है वो आर का लेंथ है, वो मास का लेंथ नहीं है, इसलिए मुझे dm का लेंथ चाहिए. तो मुझे ये बताओ देन dm वुड बी व्हाट, व्हाट वुड बी dm? लेट मी नो, लेट मी नो स्टूडेंट्स, लेट मी नो. सी देखो ये जो लेंथ है ना, जो मैंने बोला ये जो लेंथ है ये क्या है, ओके सॉरी इट शुड बी उल्टा, जस्ट अ सेकंड सॉरी. यू नो दैट जो पूरा मास का लेंथ है वो पाई आर बाई 2 है, यस और नो, यस और नो स्टूडेंट्स? टोटल मास का लेंथ व्हाट, पाई आर बाई 2 है. तो मैं ये बता सकता हूं मुझे जो जो इस आर का लेंथ है ना, जो इस आर का लेंथ है, इस आर का लेंथ है, उसका मास क्या होगा फाइंड आउट करना है. यस, दैट वुड बी डीएम, यस और नो? जो यहाँ जो मास आ रहा है ना, यहाँ जो मास है वो मास क्या है, डीएम है ना, यस और नो स्टूडेंट्स? यहाँ जो मास है, ये जो मास है वो डीएम है ना, वही हमने किया. Is it understandable or not, sir? Or it is confusing or not? Let me know. Because I'm not able to get any response from your side. Let me know, students. I'm waiting for 2 seconds to grasp everything. Okay, I'll repeat it. I'll repeat it. Others? Davangere students, Bagalkot, North Canara, Vijayanagara, Yadgiri students. See, this is very mathematical equations, okay? So I can't make it more interesting. I don't know, like, these are equations. तो कैसे कर सकता हूँ? है कि नहीं? Yes, okay. Now, sweetie, you know that, yes, you know that ये जो है, ये लेंथ है ना, ये वाला लेंथ है, ये किसका लेंथ है? ये डीएम मास का लेंथ है, सही है? क्या सही है? आपको पता है कि अगर मुझे टोटल चेन का मास चाहिए, ये टोटल चेन का मास है कि नहीं? मुझे ये बताओ जो टोटल चेन का जो मास है एम, उसका लेंथ कितना है? उसका लेंथ पाई आर बाई 2 होगा ना, मतलब टोटल मास का लेंथ पाई आर बाई 2 होगा ना. सही है, यहाँ तक सही है? क्यों? क्योंकि आपको पता है अगर ये सर्कल था, ये अगर सर्कल था तो मान लो आप इधर थे, आप यहाँ से सॉरी आप इधर थे, इधर से एक चक्कर मारा तो टोटल लेंथ क्या होगा, 2 पाई आर होगा. लेकिन आपने आधा चक्कर मारा तो क्या होगा, पाई आर, पाई आर बाई 2, ऐसा नो सॉरी पाई आर. एंड अगर आपने सिर्फ 1 बाई इसका आधा मारा तो कितना होगा, पाई आर बाई 2 होगा. यस स्वीटी, लेट मी नो. Now as I said, I got this length as what, this length मुझे क्या मिला, मुझे मिला आर डी थीटा. लेकिन मैं ये बता सकता हूँ ना, ये जो लेंथ बोल रहा है वो क्या, डीएम बोल रहा है ना, मतलब स्मॉल मास बोल रहा है. तो कहना है सेल, ये जो डी आर थीटा जो दे रहा है वो दे रहा है क्या, डीएम, ऐसा नो, ये डीएम मास दे रहा है. सो कहना है राइट डीएम इक्वल टू, डीएम क्या होगा, ये डीएम दे रहा है ना, सो डीएम इक्वल टू क्या होगा, लेट मी नो. लेट मी नो स्टूडेंट्स, व्हाट इज डीएम ओवर हियर? अगर मैंने इसको क्रॉस मल्टीप्लाई किया तो क्या होगा, लेट मी नो. अगर मैंने इसको क्रॉस मल्टीप्लाई तो किया तो क्या होगा? देखो ऐसा हो जाएगा, आर डी थीटा एम डिवाइडेड बाई पाई आर बाई 2 हो जाएगा। जस्ट अ सेकेंड, ओके, हमारा पेजेस भी खत्म हो गया क्या? हमें अगर देखो क्या हुआ, मुझे पता चला मैं पाई आर बाई 2 के लिए मुझे पूरा मास मिल रहा है, लेकिन आर आर डी थीटा के लिए क्या मास मिल रहा है? वो मास बेसिकली डीएम है, तो मुझे डीएम चाहिए। तो डीएम क्या होगा? आर डी थीटा डिवाइडेड बाई पाई आर बाई 2। So can I what? Cancel out R and R. Will I get dm is equal to what? 2 d theta by pi. Yes or no, students? Let me know in the chat. Yes or no? Okay, there is mass, and this is mass. Yes, very good. Path, very good, sweetie. Yes or no? Let me know. Okay, in the meantime, I'll be solving this, okay? So it is taking more time. So I'll be launching the NPS poll. Please answer the NPS poll too, okay? ये अभी खत्म नहीं हुआ है, ये अभी खत्म नहीं हुआ है, ओके? सो आई एम लॉन्चिंग द एनपीएस पोल, प्लीज आंसर इट नाउ। देखो हमें इसको क्यों किया? हमें चाहिए था व्हाट? इंटीग्रेशन ऑफ पोटेंशियल एनर्जी इज इक्वल टू इंटीग्रेशन ऑफ, हमें क्या मिला था? क्या मिला था स्टूडेंट्स? डीएमजी साइन थीटा। तो मैंने क्या बोला कि हमें ऐसा करना पड़ेगा कि आइदर इट शुड बी इन डीएम और इन डी थीटा। ऐसा नो? यस, वेरी गुड। अगर ऐसी बात है तो कैन आई राइट इंटीग्रेशन ऑफ डी यू इज इक्वल टू इंटीग्रेशन, ये कहां से? 0 से पाई बाई 2 तक, 0 से पाई बाई 2 तक। ऐसा नो? एंड व्हाट इज डीएम ओवर हियर? वी गॉट डीएम, डीएम इज 2 डी थीटा, 2 डी थीटा एम by pi into sin theta. Yes, so will I get integration of du is equal to 0 to pi by 2 is equal to 2m by pi sin theta d theta. देखो अगर मैंने du को इंटीग्रेट पूरा किया तो मुझे क्या मिलेगा? पोटेंशियल एनर्जी विच इज इक्वल टू, इसको मैं 2m बाहर निकाल दूंगा, इंटीग्रेशन ऑफ 0 to pi by 2 हो जाएगा इंटू साइन थीटा डी थीटा। मुझे ये बताओ इंटीग्रेशन ऑफ साइन थीटा क्या है? व्हाट इज इंटीग्रेशन ऑफ साइन थीटा? बताओ, व्हाट इज इंटीग्रेशन ऑफ साइन थीटा? लेट मी नो स्टूडेंट्स, व्हाट इज इंटीग्रेशन ऑफ साइन थीटा? So I'm substituting, what I did, I substituted this over here, बस और कुछ नहीं। साइन थीटा का इंटीग्रेशन क्या है पता नहीं है क्या? इट इज इंटीग्रेशन इज, वेरी गुड, we'll get u is equal to integration of 0 to pi by 2, 2m क्या है? 2m by pi, and we get what students? और इसका sin theta d theta, इसको इंटीग्रेट किया तो 2m pi, इसका क्या आ जाएगा? माइनस cos theta by 0 to pi by 2, and we get what students? अच्छा इधर एक कुछ और मिसिंग है क्या? कुछ मिसिंग है? कुछ तो मिसिंग है ना? डीएम, यहाँ एक आर भी आ रहा है। यस, यहाँ भी एक आर भी आ रहा है, एक और मिसिंग है आर, एंड देयर इज दिस आर, ओके? हमने जो लिखा था उस टाइम उसमें आर भी है ना, प्रीवियस, ओके? इसमें आर है ना, देखो आर भी है, सो हमने वो मिस किया था, ओके? जी भी, अच्छा जी भी है, यस यस यस, वेरी गुड वेरी गुड, यस, एक जी भी मिसिंग है, एम जी r into g. Yes, very good, very good. Now if that is the case, I'll get 2 mgr, ये मिला, so u is equal to 2 mgr pi, इसको मैंने अगर माइनस लिया cos theta 90 degrees, what? 0, माइनस माइनस प्लस हो जाएगा, ये 1 हो जाएगा, and what potential energy we get as mgr by pi. Is it good students? This was the potential energy for the chain, for the chain. Yes or no students? ये बहुत बड़ा था ना, that's too much. Did you get it students? Yes. So students, your homework is basically, I'll tell the homework, you need to solve this question again. Try तो obviously करना पड़ेगा, लेकिन आपको solve this question. Solve this question again. Okay, solve this question again. Okay, yes, is it good? And students who haven't answered the NPS, please answer the NPS. Okay, Harish, are you available in the chat now? Let me know in the chat. Okay, I'll summarize and I'll clear your doubt. Okay, I'll summarize and I'll clear your doubt. Are you present, Harish? Let me know in the chat. Okay, yes, everyone has to answer the NPS. Please answer the NPS. Okay, Harish, very good. Now, if that is the case, students, in the tomorrow's class, we'll be talking about spring potential energy. Okay, this is very, very important. So please don't miss the class. Okay, so please don't miss the class. So students, today we talked about what? We talked about what and all we talked about. Basically, we were talking about potential energy. In that, we talked about gravitational potential energy. Yes, gravitational potential energy. In that, we came to know that what gravitational potential energy was. What students? Let me know. Minus G M M1 M2 by R. Yes or no? Here, don't worry. This will be proved in our what gravitational chapter. Yes or no, students? Then we talked about what? There was this question where there was this chain problem, and we came to know that the potential energy for this is what? 2 mgr by 5. Yes or no? Students, let me know. Is it clear till now? Yes. So that's all for today, students. Thank you for attending today's session. And also, students, please answer the NPS. Okay. So yeah, students have left who haven't answered. Okay, I'm ending the poll. Yeah. So thank you for attending, students. Yes. Harish, your doubt. Okay. The doubt was in gravitational potential energy, है ना? क्या था? Okay, Davangere students, thank you. See, over here, the thing is, in gravitational potential energy, there are two masses, that is M1 and M2, and it is kept at a distance r. We get to know that the potential energy of the gravitational or gravitation is minus G M1 M2 by R. ठीक है? लेकिन इसमें assumptions क्या करते हैं? Assumptions करते हैं कि सरफेस का जो पोटेंशियल एनर्जी है ना वो जीरो है, ठीक है? और जब हम उस एक बॉडी को उस सरफेस के से एक हाइट h पे डालते हैं ना, लाइक इफ यू टेक दैट ऑब्जेक्ट फ्रॉम ग्राउंड टू दी व्हाट द सरफेस, देन उसका जो पोटेंशियल एनर्जी आएगा ना वो mgh आएगा, ठीक है? एंड ऑलवेज रिमेंबर दैट दिस h जो h रख रहे हैं ना वो h इज नॉट वेरी लार्ज, ठीक है? एंड मींस क्या, h बहुत लार्ज नहीं है. जब तक h बहुत लार्ज नहीं है वैलिड हो. इज इट गुड? यस. एंड ये वाला जो था ये एक प्रॉब्लम था जहां हमने चेन रखा था एक एच पर, इस एक और चेन पर रखा था ऐसे वर्टिकल, दिस इज वर्टिकल, और एक और रखा था सरफेस के पास, एक और रखा था हमने सरफेस के पास. बस इतना ही था. यस हरीश, वेरी गुड. Okay then students, thank you for attending today's class. Okay, bye bye, take care everyone who is present over here. I'll be ending the class. Okay, is it good? Should I end the class? If there is any doubt, please feel free to attend me. Okay, or let's say contact me. Take care, bye bye. Yes.